Hello. Thank you for joining me. Wowza. Okay, let's go on. This is me. I'm Carlton Gibson. I'm at Carlton Gibson on GitHub and Twitter. You can find me there. If you type those in, I get messages and try to respond. Who am I? I'm one of the Django fellows. Sorry. Together with my colleague Marish over there, I'm one of the current Django fellows. We're contracted by the DSF to do the sort of day-to-day running of the framework. We do ticket triage, patch review, security releases, handle the releases, all the things like that. Together with all our fantastic contributors, which all of you lot, yes, we keep the framework running. Django is of a size that there's too much work to be done on a purely volunteer basis, and so the fellow program was created to create that. So let's just say, sponsor the DSF. Your contributions to the DSF, either as an individual or ideally as a company, help to secure the sustainability of the framework. You make a small investment that's a bit like insurance. Right? It keeps the framework that you've built your business upon running. So, I'll say that. When I'm not fellowing, I help maintain various packages in the Django ecosystem. The ones that are relevant today is the channels trio of packages that was started by Andrew, but that I took over a few years ago. The brand new releases out for all of these three packages, channels, DEFNA, and channels Redis. That's been going all summer trying to get out the door. I finally got the time to write the release notes on the phone, on the plane coming over here, where I refused to get onto the Wi-Fi, and I'm like, no, I'm going to write the release notes. I got it out, and so I was able to release the channels version on last Saturday from Will's house in Boston. Speaking of Will, nothing to do with this talk, but we also have a podcast called Django Chat, DjangoChat.com. Do check that out. What we do is we get people from the community and we chat about Django, so check that out. Today's talk is about Async Django. Async is one of those buzzwords. It's an exciting topic. I think there's a lot of confusion about what it's all about. So there are questions like, well, what's all this async? What is it good for? How do I use it? And so on. So I've titled this talk, or I've tagged this talk, the practical guide you've been waiting for. Sorry about the pun, but once I thought of it, it was inescapable. Async's a big topic. There's a whole load of depth to it, and there's a whole lot of very, very clever people who spend a lot of time working on it. Now, that's more than we can talk about today, but as Django developers, it's more than we need to worry about most of the time. So what I want to do is go through a few examples of async and bring out some of the key things that I think are most relevant when you're applying async in your Django application. The bottom line is that using async makes your application more complex, like 100% more complex. So my hope is that you leave this talk with some ideas so that when you decide that you do want to use async, you don't make it too difficult for yourself. Right? So let's go. We're going to start with a simple async IO example. And we're going to do that just to bring out a couple of ideas that come up later. So let's begin. First of all, we import async IO. Async IO is the Python standard library's implementation of an async runtime. It gives you an event loop and lets you schedule concurrent tasks that will run on it. There are other async implementations in Python, most notably the Trio project. We don't need to worry about those as Django developers. Async IO is the main option. It's the one that the standard library provides, and it's what Django's async support is built on, at least for now, right? So with async IO in place, we can define a couple of helper functions. We'll define one that just prints a dot every second. And then the second one, we'll give it a couple of parameters, a task name and an amount of time to wait. It will just print when it starts, it will print when it's finished, and it's something to see. Okay, a couple of things I want to draw out there. The key syntax, which is the async and await syntax that we use to mark async functions and signal to async IO that we're ready to pause our function normally while we wait for our IO, but we're just using sleep here, and we'll give back control to the event loop so it can go and do something else. An async def function is called a coroutine, and when you call it, it doesn't actually run its code, it returns a coroutine object, which is called coroutine object, helpful, hopefully similar names, but and then you can await that coroutine object with the await keyword there, and that will get your event, your code run on the event loop. When you await a coroutine object, your code is paused, the event loop handles running it, and sometime later, you'll get the actual result of your function, and your code continues from where it left off. So let's look at that. Here's our main function. First, at the top, we use the async IO create task to schedule our print every second coroutine to run. Then we create 5 tasks with a name A to E and an amount of time to wait. Then there's an important step. We gather those tasks to wait for them to complete. That's a bit like calling join on a thread, if you ever use that kind of API. Then at the bottom, we use async IO run, which is a utility function which will create an event loop for us. It will start it, and it will run it until our main function completes. Okay. So the whole thing looks like this. You still see that? Okay. Let's run it. This is the output that we get. Our 5 tasks, A to E, start. Then we get a dot from our print every second one. Then A finishes, B finishes, and then we get another dot. It's a bit curious why there isn't a dot between A and B. Like async IO has a kind of list of tasks, a queue of tasks, and whichever one gets there first will get run. And I didn't dig into exactly why it comes out this ordering, but it's kind of nice that it did for the example. Let's just see the example if I forget that important gather step. So without the gather step, what happens is this: all our tasks start, but then the main function finishes, and our event loop is shut down. So our poor print every second function, it doesn't get to do anything because it was shut down before the end of that. So we need to not exit our main function because we need a running event loop to execute our concurrent tasks on. So look, if I go back, it says, hang on, important, wait for all the tasks to complete. If we take that out, we get this problem here. So thinking about Django, the first question that comes up when the async word is mentioned is, well, can I use this for background tasks? A user signs up. You want to send them an email so they can click a link to confirm that they entered the right email, but we don't want to spend 5 to 10 seconds with the browser not doing anything before sending back the response. So could we use async IO to send that email? Could we use create task to send one in the background? Well, my old man answer here is, well, it kind of, and it depends. So can I use, let's go through both of those. So can I use this for background tasks? Well, kind of. The question is your task going to fail? Is it going to go wrong? Can something blow up? Because there's no built-in statuses, or retries, or error handlings, or any of that if you just fire off a coroutine with create task. Okay? You could write all of that, but in reality, you're going to want to use a system that provides that for you, like Django DBQ, or DjangoQ, or Celery, even if that's your cup of tea. Maybe someone writes a queue implementation on top of async IO that provides these nice utilities, but you don't really want to be writing them yourself. Now, you're all adults, you can do what you want. Maybe your code doesn't, you don't do any error checking anyway. You're not checking retries, so, blow it, let's go. Maybe for simple tasks that aren't likely to fail, yeah, okay, fine. But you can use it. But can I use it for background tasks? Well, it depends. It depends on how you're running Django. So we come back to this thing that's been mentioned loads of times this conference already about WSGI and ASGI. WSGI is the standard for Python. It's the synchronous standard for Python web frameworks. ASGI is the asynchronous standard for such. Simplifying, a WSGI app gets the whole request at once, and then it returns the whole response in one go as well. It's kind of like one shot. An ASGI app is event-based. It has a pipe for incoming events, and it has a pipe for outgoing events, so that communication can be long-lived, or bit by bit, or two-way. The point is that in general, under WSGI, there's no running event loop. So when we hit an async view, an async def view that is supported under WSGI in Django, we spin up an event loop to handle the request, but it's stopped as soon as the view returns. Okay, so that's going to be exactly like the example, the async IO example, when we didn't have the gather call. Your background task that you spin up with async IO create task is going to get shut down as soon as we stop the event loop. So if you're running under WSGI, you can't use create task to schedule a background task. If you're running under ASGI, well, yeah, kind of. So let's look at another example, aggregating views. this is my favorite, really. What I like to call it is what we did before we had GraphQL. So let me talk you through the example. The basic setup here is that you have an app for hotels. It's got hotels, it's got rooms, and rooms have rates. And you have a couple of Django models for that. You have a hotel and a room with some rates. Okay, you have some basic Django REST framework serializers. We've got a serializer for the hotel, a serializer for the room. Okay, and we have a couple of Django REST framework views. We've got a hotel detail view that will just show the hotel, and then a room list. You'd probably have other views in your API, but this is all we're having here. And then those views have URLs. Now this is all great, does everything, except your mobile team comes along and they say, we don't want to make 2 requests to get both the hotel and the matching rooms with their prices. We need that all in one hit. And quite rightly, even these days mobile connections are slow and they take a long time to connect, and they use battery and they use data, and we want a responsive web app. What we want is a single view that fetches all of the required data in one go. Now this is exactly the use case that GraphQL was created to solve, but you don't necessarily need to take all that on. You can have an aggregating view. So let me just put it up, and then we'll go through it bit by bit. So at the top, first of all, we're going to import a library called HTTPX, which is a async requests library for making HTTP requests. And then we're going to import the bits that we need for a JSON endpoint. Yeah, just JSON response and view and such that. Then we're going to define our view with an async def get handler. From Django 4.1, we can define async def handlers on view subclass, class-based view subclasses, and so we've got a nice namespace that we can decompose our view logic into if we need to. You could do this with a function-based view. You could just get rid of the class, and you could get rid of the self argument, and you could move it, outdated one, but it would work exactly the same, but you wouldn't have a namespace, so it's up to you, whichever you prefer. Then, with our view boilerplate in place, we can get the URLs for the views that we want to aggregate. This is the hotel detail view and the filtered room list for that view. Then we can use HTTPX's async client to fetch the URLs concurrently. The client.get method is an awaitable. And we use the async IO gather method to wait for all the tasks, essentially the slowest one, to complete. Okay. With those there, we finally compose the response structure that's needed by our front-end team, and we return the response. Okay, so it looks something like this. We make the request. This is what the response looks like, and the mobile team are like, great. And then they come along and they say to you, oh, can we have an extra field? And you say, yeah, no problem. Let's just adjust the mapping that we had in our view function there. You can even train them to do this, by the way, because once you put the boilerplate in, the structure in place, it's really easy to adjust the mapping. And you can say, well, yeah, if you create a ticket, I'll do it in a couple of days, or you can just do it this afternoon. Okay. The day before release, marketing turn up and they say, oh, by the way, the hotel detail view, it needs to pull weather from the weather API, and we need to display weather on the hotel detail view as well as the rates and the rooms. And you say, no problem. You just add an extra call into that list of concurrent requests that we run, and then you map it into the request data. It's a very simple pattern. It's a pattern I've used for many years. Async IO didn't exist, and so we used to use Node.js. And we could have done it with Python threads maybe, but you didn't do that. You used Node.js. You'd spin up a little Node service next to your Django app, and you provide the aggregating endpoint, and now we can just do it with Django. Right? The best bit about the aggregating view pattern is that you can do this with your existing WSGI app right now. You don't need ASGI. You don't need to worry about async. You can just write this one async view that gives you this aggregating view pattern. Job done. As Djangonauts, that's quite exciting, I think. Okay. So for the last example, I want to go through a chat app, and I want to go through it 4 different ways. We're going to do it 4 different ways so I can show different approaches to how you take a basic app and you add reactivity to it. So let's go through the setup quickly. We're going to build a simple app that lets you post messages to a single list, like the old guest books that you would have built in the late 90s. You know, you've got list of posts, they'll add your thing, message board there. The officials channel tutorial has a similar multi-room example that uses WebSockets, and that's worth comparing with later on, but this is just a single room example. So let's start off. We've got a Django model. It's just a message model. We have posted by, it's just a string field because we don't want to get involved in foreign keys to users or anything like that. We're just going to have some text for the for the message, are created at, updated at, end. Yeah. We'll have a form and a filter. So we're going to have a Django filter there that will enable you to say, look, I just want the messages created since a particular date. There's a nice little trick here from Django filter. Nobody likes created at as a URL parameter, right? So if you put since there as the name of the filter field, and then you have the field name that it points to, you can name your query parameters however you like to name them. It comes up quite a few times on the thing, on the issue tracker there. So then, and then we'll just have a form, a model form for posting our message, and a couple of fields. Let's have a view. This is going to be a message list view, but let's go through it bit by bit. At the top, it's a Django generic list view. So we have our model, template, context object name, and an ordering. Then we define the get query set method. We just get the query set. We run it through the Django filter set, and I'm just limiting it to the 30 last messages in case it's 400. I don't want 400. Get context data. I'm just overriding this so that if there's session data saying who it's posted by, it will just populate the initial value in the form with the posted by so that people don't have to keep entering their name if they put multiple messages in. Okay? And then with the get template name, I can just add this if it's an HX request, which is a header set by HTMX, not HTTPX. I get confused with too many X's, which is the library we're all loving these days. And then that's the view. Then we're going to have a post view for messages, which is a create view. So you post in, it processes the form and creates the object in the database. 2 bits to pull out there. I'm going to set the success URL to go back to the list view. I'm not going to have a detail view. It's just the one list view that we've got. And then if the form has the posted by data, we're going to put it into the session so that we can reuse it next time. They don't have to keep entering their name. Okay? So that all works. That, you could have those 2 views together. You've got a list view, post a message, it'll appear. But question, how do we get updates? Right? I've got it in front of me. I want to see if someone else posts. So that's the reactivity that we're going to look into, that we've got the 4 examples for. The first is polling, where we just go and refresh the list and see if we've got a new one. We're just going to use HTTPX for this. Okay, so HTMX, sorry. We're just going to use this lovely HTMX thing that we all love. All you do, set where you want it to go, set the URL you want it to get, set the target that you want it to go to, and we've got a trigger here. So but this is just a checkbox. If I check it, it'll start polling, and then every 5 seconds it will go along and say and refetch again. And that might well be enough. And if it is, well, stop there. But scaling. Having lots of clients repeatedly making requests, well, perhaps you might run into problems. What about responsiveness? The other concern is responsiveness. 5 seconds might not be too long, but maybe I want to get quicker updates. Some checks, no, there's no update, then half a second later there's a new one. I have to wait the whole polling interval for the update. I could poll more frequently, but then that scaling slide, that starts to become more problematic. My app essentially gets to the point where I'm doing a self-DOS on my, I'm denial of service attack on my own application. Okay? So this is where we need a second strategy. This is where we start to introduce something else. And that second strategy would be long polling. And here we go beyond what Django can offer itself. Async kind of changes the schema of how we make requests. So traditionally, we go from we've got a request response thing. We send a request, we get a response. And we go to an event-based model where we get a request, then we wait for an update somehow, and then we send the response. And it's the waiting is what means that we really need async. Under ASCII, each request is treated like one of those concurrent tasks that we had in the first async IO example. And if they're just sitting around doing nothing, then for all intents and purposes, we can have as many of them as we like without overwhelming our server. But by moving to ASCII, so we can wait, and we can also handle our issue with too many simultaneous connections because we're not overloading our server. We also need a way to respond to events that communicate between requests. So for this, we need the channel layer. We need more than Django provides itself, so we need the channels package. And the channels package has a couple of parts that I want to talk about. So just got tense, but in fact I'm running out of time. The first is channels, gives you a channels layer, and that's a way of sending messages between different connections. So I've got a browser window open, someone else has got a browser window, someone else has got a browser window, and I want to communicate updates between them. How do I do that? Well, I need a channel layer. Essentially, we're going to post to Redis, and Redis is going to send out an update to each of those. And then the second one is consumers, which are essentially high-level abstractions on top of ASCII, which make writing your async applications a bit more Django-like, a bit more human. All of this is in the channels docs. If you want to follow the channels tutorial, that's great. But I'm going to give you I just want to run through an example quickly. First of all, we need a way of notifying when there's a message. So when we get a message, we have to grab the channel layer, and then we have to post that. We have to post a message to a channel, and each message, the message here will have a type of chat.message. That's the type of message we're getting, and we're going to post it to the chat group. Let me push through because I'm running out of time. Then we're going to use that notify method in our form valid message on our post view. When the form gets saved, we'll send off this notify that there's new messages. And we do that on transaction on commit because we want to make sure that the message is actually in the database before we go and tell all our other clients to fetch it. Otherwise, they're going to go and it's not going to be there. And well, hang on, what's gone on? That's it. So that's all that's the change we need to notify, and then we just need to listen to it. So a channels consumer, we set it up with to connect to the channel layer and say, hey, we're here. When we disconnect, we remove ourselves from the channel layer, and then we just send some headers. Let's skip that bit. Sorry, I'm just realised I'm going much slower than I should have been. Then we define a helper method to fetch the messages from the database and render them in a template. Now we could use the new async ORM query methods here, but template rendering is a CPU blocking operation, and so we're going to want to run that in a thread pool, because otherwise we block our event loop, and we can't handle lots of requests if we block our event loop, and we can't pass ORM objects into a thread pool because ORM objects aren't thread safe. So it's much better just to fetch them all in one synchronous function and do the fetching and rendering in one, rather than trying to cross that async-sync boundary too quickly. And then we just define one more method on the handler, which is this chat message handler. So we send a message to the channel layer of a type chat.message, and channels knows to map that to a function chat underscore message, because you can't have Python identifiers with dots in. That's not a valid identifier. So there's this mapping between message types and the handler that's going to be called. The sync to async function enables us to call that synchronous function in our asynchronous context in a thread pool and get the result, the HTML, and then we just send it over send it over the wire. And the key bit here is this more body false, and that says there's no more body to come, so can you stop the connection? And that's how we get our instant reaction. As soon as the message is posted, we'll get an update. Our consumer will receive an update saying, hey, you need to fetch the messages, and then it can render the HTML, send it across. Okay. And HTMX will do the long polling as well. Okay. Now that's great. It's exactly what we wanted. But with long polling, we get a chat message for every single request, and it's like saying, well, what are you doing? What are you doing now? What about now? What about now? And it's lots and lots of connections, and we might want to reuse those connections. So can we keep reusing? Well, yes, we can. And so for that, we'll use server-sent events. And it's exactly the same. We set up a channel's consumer, we connect to the channel layer, we disconnect from the channel layer when the connection ends. We've got the same message list HTML renderer. The only thing that's different is the chat message handler, the handler that actually does the updating. And the only real difference there is we're formatting the event for a server-sent event, because server-sent events are new line delimited, so you can't have new lines in your event body, otherwise you get an injection attack. So we have to format it particularly, but then we just say more body true when we send the event across. And that more body true says, hey, and don't close the connection, I'm going to get another one. So I can keep reusing the same connection, and Bob's your uncle. Again, HTMX has an extension for server-sent events, and you're there. The final example, the final option is WebSockets. And these are very popular, they've got good library support, it might be what you jump to straight away. WebSockets, again, keep the same connection open, but they allow two-way communication. The long polling and server-sent events examples only let us send data from the server to the client, whereas WebSockets can go back. So we could rewrite the post form to use the WebSocket. We're not going to rewrite the post form. We're Djangonauts. Okay, so it's exactly the same. I change the import, and in connection, I still connect to the channel layer. On disconnect, I disconnect from the channel layer. I still got the same HTML helper function. And here in the chat message, I just use the WebSockets bit to send the data across. And this is the genius of the channels package, is the abstractions hide all of the differences between these packages, between these options for you, and you can write almost the same code, just changing a few bits and bobs here between them. Anyway, that's it. Channel app 4 ways. Which should I use? Okay, polling is simplest. If you've not got a lot of clients and a lot of requests relative to your response time and a small delay doesn't matter, then just use that. If you're building an internal facing app, it's likely all you ever need, right? If you've got lots of clients though, lots of connection, then that's when you want one of the other three. From Django 4.2, if it's at all feasible, we'd like to have a story for streamlining async responses. So you can do the polling or SEO examples just within Django. If you want real-time responses, then you need one of the async examples because of that latency. If you want two-way, you've got to use WebSockets. You might use WebSockets anyway because they've got better library support. You know, if your library uses WebSockets, just jump to those, right? So the normal answer is, well, it depends, okay? Two very quick slides and then really we will stop, Katie. Getting it online, we said at the beginning WSGI or ASCII. What about WSGI and ASCII? Async is really complicated, and it's new, and we're all still discovering how it works. And I don't just mean me and whoever else, I mean everybody is still discovering how it works. On the other hand, WSGI's got 15, 20 years of solid experience. Do most of you out there and have a little side one just running a couple of WSGI endpoints. Double check everything. Most of the problems I see on the channels repo are configurations with loud balancers in platforms of the service. Like, take the time to go through it and then have fun. Literally, async it's like catnip, right? So have fun. What are you waiting for? Bye.